All right, we get started now, I guess, in 30 seconds or so. A few more people coming in the door. All right. Good morning, everybody. I'm Ciaran Dynes. I run product marketing, product management for Talend. I'm here with Remy Dubois. Remy is kind of like principal engineer for our big data technologies at Talend. And delighted to be here today. What we're going to talk about and run you through is Talend's sort of answer for big data. And you would have seen some of this morning. Sean Connolly, I believe it was, from Hortonworks, did a bit of a screen sort of capture or walkthrough and give you maybe a bit of a flavor for what we do at Talend, because the tools that he demonstrated as part of the Hortonworks distribution, we provide part of that to Talend, and it's part of that to Hortonworks, and it's part of the Hortonworks distribution. So the goal of Talend is very, very straightforward when it comes to anything to do with integration, but in particular for big data, it's all around democratizing. And our democratization story is just making things simple, making it easier, more accessible, and that's our whole open source ethos. We give away, and invest a hell of a lot of time and effort in working with our community. I also spent a lot of time with the Eclipse community and the Apache community and various other different types of open source initiatives that we're involved in. And our whole goal has always been to disrupt, be democratic, partially because of our European ethos, I guess, coming from France, where the company was founded. And when it comes to big data, it's no great surprise. The whole idea, again, is a certain amount of technology is available through the community as part of our open source tools. And then thereafter, we provide commercial support, we provide enterprise-grade management and other types of capabilities around that. So I know the conference is all around big data, but our sort of area of expertise is big data integration. So very related, I guess, to big data is how do you get your data that's in your enterprise, how do you connect it with new data, and how do you exploit it? And we're all about that, connecting the data. How do you take the existing enterprise data and mash it up with new data that you may be getting from other sources? So integration does form a big piece of the puzzle when it comes to big data and big data technologies. We talk a little bit about Talend strategy, which is kind of this little play on words and big data for the masses. Today big data is really it's a small number of people that know how to write MapReduce code. And I guess the game that we're in is, could we make it more broadly adopted? Everybody in this particular conference, all of the vendors here, really think it's an exciting time around what we're doing with big data. And the whole idea is to try to push that technology as far as we can and make it usable, consumable by everybody. And when we look at big data for the masses, Talend's whole thing is, can we get a different class of developer to exploit this technology and be part of this big movement? And then we look at where are we going to next, a little around big data quality and big data management. So going beyond maybe what we can do today with Hadoop and looking a bit more around data quality, which for us is probably the biggest thing that we really need to address and tackle for very good reason. You can take a lot of data, you can mash it together, and you can end up in a world of hurt. It's no different than we've had from classic integration issues down through the last decade or so. So when it comes to big data, we feel that you could exacerbate that problem if you really don't have a good data quality program, or at least an idea of what your plans would be around big data quality. So our goal, won't dwell too long on it, but as I say, for Talend, it's all around basically democratizing integration. And we're the leading open source vendor in the integration space, providing technology around data, application, and business process management. And we're recognized as the open source leader in many of the market categories by industry analysts. Brief background, technology is freely available to download, about 20 million downloads of the technology thus far. About almost 1 million users of the technology in various different sort of guises. So, we span a full spectrum. We've got data, we've got ESB, we've got BPM, a range of different things, but many people are very familiar with TOS, which is the Talend Open Studio for big data. And really what we're going to show today is the extension of TOS, specifically around big data components. So in a nutshell, if we can basically just say, well, what is Talend about? We're going from this, which is this complex cluster of MapReduce and MapReduce code, to this. And we're basically trying to simplify that whole interaction with things like Pig and HBase and Hive and Scoop and all these wonderful different things. But in essence, what we're providing you is a full development environment with pre-configured components that allow you to basically do a data integration job. Take data from your weblogs, maybe at Apache. Take data from your existing databases or CRM systems. Take data from Salesforce.com, whatever it may be, and mash that all together and put it into a Hadoop cluster and then basically exploit that information. And that's basically it. That's what Talend does. It basically provides tools that make that whole job a lot easier. So I think listening to Hortonworks this morning, they've got this great definition of what big data is all about. You know, we hear about velocity and we hear about variety and we hear about the last one, which is volume, which is one we shouldn't forget. But I kind of prefer this particular definition, which is the whole nature of what the data actually is about. So transactions, interactions, and observations. And that's, you know, where you get your actual data from. So if we look at this graph, which we'd seen earlier this morning, which is very, very good, you're kind of looking at, you know, on the left axis, you know, megabytes, gigabytes, petabytes of information. And on the bottom axis, you're looking at the, you know, increasing of the complexity and the variety. So you look at ERP information. This is classic sort of, you know, enterprise data that everybody has and everybody uses for different types of business analysis. CRM, obviously looking at your customer data, you know, lots of different things that you can do in there. But where it starts to get interesting is when you start bringing in weblogs and web information, you know, looking at sentiment, looking at how you interact with your customer. And then where it gets into big data, you're kind of looking at the greater population. What are people saying about you, you know, in the public? And are people producing extra information that you may want to consume? And depending on the industry, some of this may be of interest to you and some may not. You know, big data could be, you know, from a manufacturing industry, there's no sentiment analysis about, you know, if you're building big machinery or big trucks, it's not that interesting. But sensory information may be critical to your business. Analyzing what trucks are basically, you know, in the mines, harvesting whatever particular natural resource you need or whatever it may be. So basically what we're saying is that this classic ERP, CRM information, and there's an abundance of other information that's outside of that normal enterprise and outside your firewall that you may want to consume and use. So what is big data integration? Well, if you think about the traditional data flow that we may have, you've got your CRM, your ERP, and whatever your finance systems or applications, and it's the classic ETL. You know, you're bringing together your various different pieces of information, normalizing that data and putting it in a data warehouse for the purposes of doing some sort of business analysis on top of that. What big data basically changes, though, is you're looking at other types of information. You're looking at social networking information, mobile devices, perhaps, in terms of the content that's being produced, maybe some amount of voice information, maybe it's images. You know, so not just the Facebook definition of an image, but maybe the images that you're collecting are, you know, to do with, you know, information in the field. It can be related to healthcare, it can be related to manufacturing, or other types of industries where images and digital images are reporting back very critical information to the enterprise. And when we look at big data, this is one of the areas that we basically look to consume. This whole notion of structured versus unstructured data. That whole unstructured data is quite complicated to basically extract meaningful information from unstructured data. And trying to get a handle on that is one of the major big you know, challenges in terms of using and exploiting big data. Transactions, network devices, and sensors, these are all just other, you know, flavors of information that you may want to use as part of your particular activity. So big data forces us to think differently, and it challenges in many different ways to say, okay, you now have all this information, what do you want to do with it? But for Talend, I guess what we would say is that that's big data, but when it comes to big data integration, it really is just more of the same. Big data integration is all about, you know, combining existing information and coupling with new information. It's really about pipelining or bringing together data jobs. You know, taking information from different sources, doing some sort of mapping or aggregation on that, and putting it into your Hadoop cluster. And thereafter, it's about basically conducting some analysis on that. So from our perspective, it's not particularly radically different, particularly for Talend. We really have developed a number of components, different technologies over the last 12 months or 18 months, And all we've basically been doing is using the same tool set that we have, albeit that we now have this tool set specialized for working with things like Hadoop and big data. So if data basically enables information and supports decisions and drives your business, when it comes to big data, from our perspective, it really is just enabling, bigger data enables bigger information, bigger decisions, and bigger business. And that's all it is from our perspective when we look at data integration. So we look at big data for the masses in terms of what we've been working on. We've been working with pretty much all the big providers and industry leaders in this space. Hortonworks in particular, we've done a lot of work with Hortonworks this year, which has culminated in the embedding of this Talend Open Studio for big data technology as part of the Hortonworks data platform. And really what we give and our value to any end user or developer is just making it simple. We're trying to make you more productive by providing an intuitive tool, and which we will, Remy will basically demonstrate today, so that you can actually take all this various different information from different systems and get it into Hadoop. And that's one of the major challenges that people have is how do you simplify that challenge? Gathering together the information such that you can actually give it to a data scientist to conduct some sort of analysis. So that's that whole idea of the big data for the masses, and it's democratizing this area of big data. So it's all available basically in this Talend Open Studio for big data. And ultimately what I say, it's about just improving the efficiency of taking information, designing it through a workflow, and then basically pushing that in and out of your cluster. So ultimately what it does is it abstracts into a piece of generated code. And if you're looking for the one unique in terms of what we do, it's this. As an open source vendor, we've always been very keen to basically generate just code. Because code basically in lots of ways is democratic. It's free, it's open, accessible, and it doesn't lock you in to any one specific vendor. So the code that we generate out of the back of the development environment is just pig code. It's just MapReduce code. It's under an Apache license, so it's free to use. And all we're basically doing is making the developers much, much more productive in terms of getting their data from their existing systems into the Hadoop cluster. And it's that simple. You don't require an agent. You don't require a special piece of technology to run inside the actual Hadoop cluster. So that's the sort of the real, I guess, significant difference. But it allows us also to optimize the running of these data jobs within the cluster. It's just code. And that allows it to be highly efficient, highly performant, and actually leverage the underlying cluster for the purposes of doing data integration. As I say, we've got support for all the major different pieces of big data, so HBase, HDFS, Pig, and Scoop, and all the rest of it. It's under an Apache license, so pretty much free to use, like the Hortonworks data platform. Anybody can download it and play with it. So let us just go through a quick demo. So Remy, as I say, basically is one of our lead engineers on the big data space. And he's been working very, very closely for the last 6 months with the engineers at Hortonworks. And we're just going to go through a range of different things you can do with the tool. As I say, it's an extension of what we've been doing for a long time with Talend Open Studio. And what we basically have built are these specialist components. And these components are available for all the various key pieces that you have within Hadoop, like Hive or Pig. And ultimately what we generate at the back end is just native code that can run inside the cluster. So Remy, I'll hand it over to you, and I'll quickly switch over the...
I will try to speak without microphone. I hope everybody will hear me. Okay? So
no, it's not going to work.
Okay. My name is Remy Dubois, and at Talend I'm leading the component team, which is responsible for creating and implementing the connectors for data integration. I don't talk about Hadoop and big data yet. I mean, we are able to connect to different databases, files type, web services, different CRM, etc. Since 3 years, Talend is trying to connect to Hadoop and big data in general. And for that, we are creating some connectors. What we have noticed is, okay, Hive and Pig, Hadoop sub-projects, are generating some MapReduce code, but it was not enough for us because you need development skill to do that. Again, okay? So our goal is to generate Java code, which will generate Pig or Hive stuffs, which will generate MapReduce. With really simple design, I will show you after. Okay, the key point of view of Talend is to democratize big data. And, okay, let's start the demo. So Talend Open Studio for Big Data is an Eclipse-based product, which is using the RCP technology of Eclipse. First of all, I will start to introduce the studio to you before talking about Hadoop in detail after. So first of all, to use Talend, you have to create a job, which is actually a Java class, okay? Like that, test job for Hadoop, for example. And you will have a palette of components which are available in the studio, approximately something like 500 components to connect to everything you want. SAP, Oracle, we have something like 25 database types supported in the studio. So for this first short demo, I will use a very simple MySQL table. Okay, just 2 columns, 2 records, it's enough to make the demo. What we have to do in Talend is just to take a component name, for example, there, MySQL input, and to put it on the canvas there. And we have to specify some parameters which are absolutely needed for connecting to MySQL. So the host, first of all, the database name, the user, the password, of course, the table name, and we have to specify a schema. So in our case, it is an ID, which is an integer, okay, and a name, which is a string. That's all. We can guess the query, which is a simple select statement in SQL. And what we want to do is, for example, to write into the console after making a simple transformation. So I'm using a very generic component in Talend, which is named the tmap, which will allow you to make the transformation very easily. And I want to write my results on the console. Okay. So to do that, I have a very beautiful mapper to make a simple mapping between my input, which is my MySQL database, and my output, which is the console, but it would have been possible to have HBase or SAP or something like that. Okay, so I just make a simple mapping. And to show you how it is simple to make a simple transformation, I will put my name in uppercase. I have an editor which allows me to do that using a Java function, which is upcase in this case. Okay. That's all. I have to validate, and I can execute my job. And you can see the result. So it is a very easy use case to show you how it works. I would have been able to use the T Apache component to get some weblogs. Ciaran was talking about a real use case in the Hadoop world. To make my demo from Hadoop, I have not chosen this use case because you will have the possibility to have this use case in the Dev Cafe during the 2 days of the Hadoop Summit. So I have created another simple use case for Hadoop. Okay. What I wanted to do there is I have some data in my HDFS cluster. And I have different technologies around my information system. I have, for example, MySQL, which contains some additional information for my data in HDFS. And I have an HR application which exports some XML data. And I would like to make some lookups with different technologies like that. So my use case is, OK, I take my data from HDFS using a very simple component. I will show you after. And then I will make a simple lookup using a MySQL table. And I will take my XML data to make another lookup on the same data. Finally, I will create some partition in Edge catalog to be able to store my data into Hadoop. So what is Edge catalog first? It is a new project in the Hadoop world, not yet a real project of Hadoop because it is in the incubator. The goal of Edge catalog is to share schema between Pig, Hive, and HDFS, streaming and MapReduce too. Before, when you were working with Hive, for example, you were writing into a SQL-like database, and it was actually a table, okay? Using Pig or HDFS, you were writing into HDFS in a file, or in a folder. So it was mandatory to know where was the data, how was the data stored into the HDFS cluster. With Edge catalog, you don't care anymore about that. You just have to write your data into a table because Edge catalog is using again the metastore of Hive, and you don't care where the data is and what the schema is. It is the Edge catalog advantage. Okay, so my job is creating a database for Edge catalog. Okay, so I just have to specify some classical parameters like a database name, a username, and some additional parameters to know if I have to drop my database before creating again it, etc., etc. Then I have to create my table in Edge catalog using the same parameters, the database name, table name, username, etc., etc. For this case, my table will contain some columns like ID, first name, last name, postal address for my different contacts, a column for the salary, birth date, arrival dates, MAC address, and department. OK. So the component T HDFS input is able to connect to HDFS using the simple parameter fs.default.name of HDFS, which is the name node URI, a simple username, and a path to the file name you want to read from HDFS. Sorry. I want to make a lookup with MySQL data and XML file data. And then I would like to make some join and some transformation on my data using the mapper you have seen before. So you can see we can do some complex stuff with. So for example, I can make a join between my HDFS data, my MySQL table, and my XML file, okay? And I can put the result in different table in output. Actually, we have there 2 different tables, and the 2 different tables are my 2 Edge catalog partition, which will be created with the data I will send to it. So I have 2 different partitions for Edge catalog in my case. One is for the contacts, for who I have been able to find the department and some other additional information in my XML file and my MySQL table. And the other partition is actually the rejects. In the XML file or in the MySQL table, I have not found the reference of my contact. So I want to treat this data differently. Okay, so I have two different partitions for that. Once you have created your job, you can save it and you just have to execute it. So just to show you, the initial data in HDFS was just ID, first name, last name, and a postal address, something like that. Very classic. Okay. You can see the statistics too, okay? So the job has finished, so I have more than 900 of rows which have been put in a partition in Edge catalog, and 300 have been put in the second partition. My second job, in my second job, I just want to read my rejects using Hive. It's possible to use Hive technology to read Edge catalog data because Edge catalog and Hive are using the same metastore. It's the goal of Edge catalog. So in this case, I'm using a Hive component, which allows you to specify your host name, a port, username and password, a schema for your query, okay? And you just have to specify a simple HQL query to read the data from your Hive table. In this case, I make again a lookup using our mapper, and I want to put the data in the console, for example. I can execute the job. And we can see the data has been written in the console. I have used the console just for tests. I would have been able to use HBase component, for example, because I want to store my rejects into database. And HBase is the Hadoop database. So I would have been able to use this output components in my flow, just linking my output flow with the table, okay? And there I have to specify a schema for my table in HBase. I have to specify different families for each columns because HBase is a columnar database. And that's all. I just would have to execute this job and the table would have been created into HBase very, very easily. Just specifying zookeeper quorum and a port. Okay. And finally, what I want to do with my not rejected data is to make some transformation on it. To do that, I am able to use pig components. And actually, each pig component in Talend is generating a pig operator. For example, the tpig load component will load the first file. The tpig distinct will use the distinct operator in pig, etc., etc. Again, there, because of Edge catalog, I am able to read my data directly from a table, a Hive table. Before it was mandatory to read directly from a file or folder, but because of Edge catalog and the Edgecat loader interface provided by the new project, we are able to read the Edge catalog partition which has been created in the first job. We just have to specify name.uri, job tracker host, hashcat metastore, and that's all. Can execute my job. Since I'm working with a single cluster node, it will be a little bit long, so okay. When this first job will be finished, I will have some data in my HDFS node. Because tpig store result will write my data into a simple file or multiple file, depends of the reducer number of my cluster. And my goal there is to read again this file to be able to retrieve the data which have been generated by pig. And for this case, my goal is to write the data using an XML format in my file system. So I'm using a very simple component named txmlmap, which is like the mapper we have seen before, but which allows you to create an XML tree very, very easily, just using drag and drop and a tree and a hierarchical mapper. Okay, it can be long, so I will stop the demonstration now. I hope it has been very helpful for you. Oh, yeah. Okay, I've seen, for example, that the tpig load component was the load statement in pig, and how Talend works. For each node, each component you can see in the Canva, Talend will generate Java code. So we are able to see the code which is generated by Talend using the code view. And which is very interesting is I have taken maybe 2 minutes to create the job by design. And, oh, sorry. I've closed it. Okay. And actually, Talend is generating more than 3,000 lines of code. That is the advantage of this kind of tool. And for example, the tpig load is generating something like, okay, tpig load result equal filter tpig load result temp by, etc., etc. So we have generated some code from the parameters you have filled in the component design. Maybe the job has finished. Not yet, so I will stop there. Thank you.
Okay, so thanks, thanks for me. So hopefully we've basically shown to everybody here. I certainly appreciate that not everybody is a developer, and may not basically understand all the various different technologies, you know, that we're basically showing or talking about. But I hope you can appreciate just one simple thing. When Ramesh shows the code, you can appreciate how much more difficult it would be for a developer to build that original code, because they have to try to understand what pig is and scoop and all these technologies. Even for developers, that is actually quite an advanced skill set. So even this week, there's a lot of training going on. So you can at least appreciate or internalize it. Yeah, that would look like a complicated task. And then the maintenance and the ongoing sort of support of that code is something that somebody has to look after. All we're doing basically is providing simple abstraction, set of components on top of that, and we generate the code on your behalf. That's it. There's no great magic to it. We're not basically requiring you to have some special agent or anything else that runs inside the cluster. The other thing that we don't get into in too much detail here, but again, very important to sort of, let's say, lead architects, is, well, how performant is this code that you generate? And the real thing to take away from this is that the code is highly performant, because it is just native pig or MapReduce code that we generate. And we can optimize that code to run in parallel. That's the other thing that we can do as part of the components. There's a set of options in there that let you specify, well, how parallelized, that's a word, should this code actually be, and should this particular data job be? Okay, so moving then beyond, quickly beyond data integration, the real next sort of challenge would be around data quality and recommendations there. So again, if you take all of your data that you may have, and you look at the use cases that, I think there was some of these use cases were discussed this morning in terms of recommendation engine and sentiment analysis and all these different things, when you start to couple the sentiment analysis perhaps with your internal customer data, you can really end up in a world of hurt, because the whole notion is, if you've got bad data that exists today, for example, you've got bad addressing information for your CRM. You're sending out a mailer and it's costing you X number of dollars in lost revenue, because you're sending out bad information to your customer base. Imagine what it would do if you try to couple that with all of this sentiment information. If it's bad, you could, and you've already got bad data, you really could end up with, an exasperated problem. So really what we're talking about is moving beyond big data and just big data integration is, well, what can you do around big data quality? So if poor data quality plus big data is big problems, I genuinely believe this is actually exponentially worse for your business if you don't have a big data quality practice, or at least good quality practices in place when you start to integrate these things. And again, as part of what we do at Talend, very much involved in the data integration space and very much involved in open source, but we also provide a range of different sort of technologies that complement that in how we address quality. So big data quality in terms of mapping, and looking at the data that exists, not only within existing enterprise systems, but also more increasingly we're starting looking at applying those same technologies within inside the cluster. So some of the methods that we would look at, two simple methods. The first one is just putting together a pipeline. So traditional sort of ETL approach, where we, as Remy showed, extract some information. We do a transformation. We may do a lookup. We may do a comparison of that data with an internal source or even an external source. There's many external sources that exist where you can buy, addressing information or whatever it might be, and that's simply just running it off host. But where we think it's getting more interesting is actually leveraging the cluster to run, data quality activities and jobs. And that's kind of the next generation of things that Talend is working on, is basically looking at, again, using the simple code generation approach, taking our existing data quality tools and our profiler tools and generating this inside the cluster. If we can do that, what it means is you can leverage the entire, multi-processing environment that Hadoop would offer. So kind of moving from ETL, as what we talked about, into EDQL. So always thinking about not just integration, but always kind of considering about, well, there's always going to be a data quality problem. So rather than thinking about ETL, we should really start changing the language and the way we talk about it to really include EDQL and data quality always as the activity when we look at any of these integrations. So the pipelining looks something simple like this. So as Remy showed, you have a palette and you can connect all these different components, and we can easily do that today with Talend. But really what we want to do is start pushing the technology to run inside the cluster. And by doing that, you get this massively parallel environment to really start looking at data quality and doing it on a billion of records, or at least let's say terabytes of information. So where to for big data? Just a kind of a summing up in terms of what we talked about. Really, today it's all around, getting access to tools and making people more productive. You can get access to Talend Open Studio for big data either through us, which are Talend. You can download it from our website, or you can actually get it through the Hortonworks distribution. So it comes kind of ready-made, ready installed to work with Hortonworks Hadoop technology. Again, as we say, it's just an Eclipse environment, support for all the major key components that you have around these open source technologies. And other advanced features that we didn't go into in too much detail, but we support things like OSI for scheduling, HCatalog for your metadata, and it's also secured. So we support Kerberos today. It's not like an advanced feature that's only going to come in the future. So you can do very, very sophisticated things with Talend Open Studio for big data. And as we say, we're working very closely with Hortonworks in really advancing the technology. They've been fantastic really for the last 6 months in helping us just understand what their vision is for Hadoop. And really, as we say, our whole vision is really around the data integration aspects when it comes to big data. And lastly, just around the open source piece, this is all open source technology that comes from open source vendors. And I think one of the things that we would emphasize today and going forward, this technology should be freely available and accessible by all comers. It's not something that should be basically held by a certain few. And we would definitely sort of echo the sentiments of a lot of the vendors that are here this week, that this is a great thing, and we should basically make it available to us all, to everybody. And that's the whole view of Talend. We're really involved in this whole democratization of integration, and more particularly the democratization of big data. So thanks for attending. I'll take any questions myself and Remy. We've had a few questions before we even got to the session today in terms of what we can do with Talend, but very happy to basically take any questions. There's 2 mics located here. If you have any questions about Talend, big data, open source, the product itself, or whatever you may have. Thanks. Yep.
No question? Okay. Yeah. We talked about the front-end portion of it, and what is the story for the back-end? Meaning, how do I do the node monitoring or distribution, and that can be, because the focus of the presentation was more on the front end, how we are putting this thing, how do we operationalize this, and how is Talend helping that?
Yeah. So how do we operationalize this? Well, in terms of what we provide, we just provide effectively a data job. And there's a couple of ways that you can manage or monitor jobs within Hadoop today. You can simply just load the application and run it manually yourself. Or increasingly, we're starting to see tools like Aussie become a way to schedule, a job. And all we basically do is we would integrate with Aussie. We actually have components that do that as part of the tool. And that allows us to basically just industrialize the sort of ongoing scheduling of reporting or whatever it may be. Now, where Talend is going with its technology around our open source, we provide management tools and capabilities, a portal for an administrator. And that's one of the things that we do is we integrate our big data technologies into that portal so you can actually schedule them as part of that interface. But that's kind of a commercial feature that we have around the open source technology. But just from a pure open source perspective, you can use Aussie to basically schedule the job. And all we basically generate basically is a pre-packaged jar file, and that jar file can be taken like any other MapReduce job and run directly inside the cluster. Okay. Good. Thanks, everybody.